Okay, welcome to the another object-oriented programming, double OP programming concept, inheritance. I would say this is the most important OOP concept in when we are looking at uh, object-oriented programming. Okay, object-oriented programming inheritance. So if you look at in this world that we are living in, we will see similar objects as well as dissimilarities. Now let's look at the animal world. Look at the dogs. They have similar properties as well as there are dissimilarities. If you look at vehicles, there are similarities as well as dissimilarities. So when it comes to vehicles, let's say we want to model it through object-oriented programming. So we have vehicle, we have a car, we have bus, we have bike. So if you go by the class concept, we have to define class for one for vehicle, one for car, one for bus, another one for bike, so on and so forth. All these classes, bus, car, and bike, they have similar properties such as start, stop, such as similar methods such as start and stop. They have similar properties, speed, as well as they have their own properties. For example, bike has a pedal. So if we are defining them in separate classes with no relationships at all, you will see we have to rewrite our code. For example, start method will be implemented in all of those three classes. Stop method will be implemented in all those three classes where you will have a in case you want to change something, in which case you want to do some modifications, you have to do modification in all of these three classes. That is where inheritance will become very handy. So let's look at a simple vehicle example. So we have a vehicle underneath which there are two sub vehicles, the car and bike. So here in a vehicle class, there are common properties which are common to all vehicles: brand, speed. Irrespective of what your subtypes are, whether it's a car, bike, or whatever, you have a brand, you have a speed. Also, they have methods: start, stop, accelerate. Irrespective of the subtype, these three methods are common. So if you look at the car class, you have the brand, speed as properties. Also, those also a property which is unique to car, which you don't have that property in a bike. With respect to methods, in a car you have a method called open trunk along with start, stop, and accelerate. In a bike, you have a method called kickstart, which is unique to bike, and there are other methods like start, stop, and accelerate. So when we are using inheritance, what happens is when we inherit car from vehicle, when we inherit car from vehicle, car will get all the methods and properties of vehicle implicitly. That's the beauty of any inheritance. If you add new method here, or if you add another property here, that will be inherited to the subclasses. Also, if you do any changes to the existing methods, start or stop or accelerate, that difference will be visible to the subclasses. So in case you have done some changes to start, that that change will be reflected on all the subclasses that are derived, inherited, extended from vehicle class. Which that means you don't have to rewrite your codes again and again. Okay, so let's see how we can implement inheritance in Java. So I'm using NetBeans. So you can see I have defined a class called vehicle, and there we have two properties, brand and speed, and we have two methods, start and stop. I haven't implemented any code. You will have some code. Now, in the main class, let me define an object on vehicle. So you will see two properties that were defined at the vehicle class, brand and speed, and also two methods that were defined at the vehicle class, start and stop. That is what you mean by object and classes, which we learned before. Right. Now let me define an object from car class. If I go back, you can see in car class, we have one method or one property called doors and a method called open trunk. So you can see a keyword here. Car is extends from vehicle. Car is not a base class, it is extending from vehicle. So when you do that, now you will see those are the properties that were defined in the car class, but you also can see brand and speed properties, which were not defined at the car class, but they were defined at the vehicle class. Because of the fact that car is inherited from the vehicle, you will get those properties to the car. Similarly, you can see here in the car class, we have a defined method. We call it a concrete method called open trunk. But start and stop, which were derived at the vehicle class, now it's available in the car class as well. Now you can see without defining those methods in the car class, this is available because of the fact that they were derived, the car class was derived, inherited, extended from the superclass, which is vehicle. That is what you mean by inheritance. Okay, so this is another modeling of a uh, vehicle, different types of vehicle using object-oriented programming inheritance concept. So you can see vehicle, car and bike are derived from the vehicle class, and then electric car and the sports car is derived from the car class. So this is multiple inheritance. So now for the sports car, since it is a child of the car and also car is the child of the vehicle, sports car will get all the methods and properties of car as well as vehicle. On this side, mountain bike will get all the properties of a vehicle, that means brand, model, type, and also the suspension method property that were defined in the mountain bike class. With respect to methods, mountain bike will get the start and stop from the vehicle class and pedal from the bike class and gear shift from the mountain bike class. So in case you want to add new functionalities, you can decide where you want to add. If you're adding that to the bike class, then that method will be available in all of the subsequent classes. Right. What are best practices in inheritance? Now, when you are implementing inheritance, make sure you have a true relationship. Car is a vehicle. Dog is an animal. Likewise. Chair is a furniture. Student is a human. Now, car is not a driver. Yes, driver is associate of a car, but car is not a driver. If its relationship doesn't make in plain language, don't use it as an inheritance. Now, second important thing is keep inheritance hierarchy shallow. So if you go here, we have 3 levels. That is more than enough. Don't make it too large. In theory, yes, there is no issues, but it will be hard to understand and hard to manage. Best practice is have it for 1 or 2 levels. And then keep the base class stable. Your base class, if you do any changes to the base class, that will be reflected throughout all the subclasses. So therefore, make sure your subclass is stable. Don't do too many changes on the subclass. And so therefore, when you are defining your parent class, superclass, you take time and do it a proper design. Design at first. You do it a proper design, well designed superclass in order to maintain. Well, if your superclass is not stable, that will have major impact to your class hierarchy. Hope you understood the inheritance concepts in object-oriented programming. I will see you in another concept in next week. Thank you.